So today's lesson, you can find it on OMHS in today's folder 12622. We're going to be covering properties of quadrilaterals. And the good news is you've learned all of these properties at some point before. We're just going to go into them with a little bit more algebra. Since when you learned these properties back in middle school, you hadn't had a whole lot of algebra yet. So now we're going to revisit those properties in our quadrilaterals and bring a little bit of algebra into it too. Okay, so here we go. First we will, there we go. Okay. All right, so we've hopefully heard the word parallelograms before. With parallelograms, we're also going to be covering rectangles, rhombi, and squares. Do these sound familiar to you? Do they sound like something you've learned about before? If they are, give me a smiley face. If they are something that you've heard of before, but you're not really sure, go ahead and give me the math face. And if you've never heard of a parallelogram, a square, or a rectangle before, go ahead, I guess, give me this frowny face. Even if it's like, I remember watching Mickey Mouse Clubhouse with my 4-year-old sister. We learned about a rhombi there, although they call them diamonds, and that bothers me. Yes, I am the one yelling at Mickey Mouse Clubhouse, telling them it's not a diamond, it's a rhombus. My husband says I'm crazy. Anyone else want to tell me if you've ever heard of these things before? You've learned them, maybe you've heard of them, you kind of remember, you really remember. All right, this is promising. Awesome. All right, so a parallelogram, we kind of had a little peek at when we learned about planes, because we drew our planes like parallelograms. They looked kind of like this. Oh, kind of, okay. And hopefully at one point in your mathematics career, you learned some of these properties. If not, let's write them down now. The first property of a parallelogram is really how it gets its name. In a parallelogram, your opposite sides are parallel. That's how it got its name. So if you're drawing the picture, you will mark the opposite sides parallel. There they are. Remember, those little arrows mean parallel, just like from back, was it Unit 3? Way back in Unit 3. Another property of a parallelogram says not only are your opposite sides parallel, but your opposite sides are also congruent. So these dudes will be equal, and so will these. Also, in your parallelogram, your opposite angles are congruent. So if you have an acute angle over here, it's going to be congruent to the acute angle that it's opposite to. And your obtuse angles, they're opposite, and they would be congruent also. One other property, it's a little bit more challenging to put in the picture, but we're going to say that consecutive angles are supplementary. Okay, and this really comes from the fact that we have parallel sides. Back in Unit 3, we learned that when we have parallel lines and a transversal, our consecutive interior angles are supplementary. Hopefully that feels familiar to you. Well, that is going to still hold. Now we're just making a shape with parallel lines. So my green angle here, my acute angle, and my other double arc angle, those are going to be supplementary. And it works for here too. So I'm going to say that this angle and this angle, because they're consecutive, are supplementary, meaning I can add them together to get 180. And then the last property that we need to know about parallelograms is that diagonals are going to bisect each other. What does bisect mean? If you know the answer to that, type it in the chat. Diagonals bisect each other. What does bisect mean? Type it in the chat for me, would you? Okay, I like that, Andrew. Anybody else? What does bisect mean? Maybe listen to the word bisect. Ooh, Artemis, perfect. Camilla, perfect. I couldn't have said that better myself. Very good, Christian. Awesome. I'm seeing a lot of good stuff in the chat. You're right. Bisect means split into two equal parts. Remember that word bisect. Bi means two, section, or sect means sections. So bisect two sections, or in this case, two equal sections. So our diagonals are being cut in half. It doesn't mean that the diagonals are equal to each other. It just means that each one is being cut in half by the other. All right, so that's a lot of properties to remember. The good news is I feel like, and maybe you'll agree with me, these properties are pretty intuitive, right? Like your opposite sides are parallel. Okay. Your opposite angles are congruent. Well, yeah, they even look congruent, right? Your opposite sides are congruent. That makes sense. They even look congruent. So hopefully these feel a little bit intuitive. So even if you didn't formally know this, you probably could have still told me information about the parallelogram before I even wrote this stuff down. Okay, so let's practice using some of those properties. And there are a lot of practice problems in these notes that we're not going to get to cover all of, but I want to make sure that we do cover a few practice problems on each quadrilateral. Let's look at, I want to look at number 3. So we're going to look at example 3 here on the board. And the reason I picked number 3 is because sometimes students miss important information. And I want to point out to you how sometimes that information is given to you. So notice in number 3, you got this like little asterisk down here and it says RT equals 30. That's a very important piece of information that if you missed, you wouldn't really be able to answer the rest of the questions. So just be very careful when looking at a problem. Make sure you do read the directions carefully, but also make sure you look for any other little pieces of information that might be given to you, especially down here under the picture. And this says that RT equals 30. So RT is here. Oh, let me try that again. There we go. Okay. Now I ask myself, what is RT? Is RT a side? Is it an angle? Or is it a diagonal? Okay, so I'm going to put a poll up on the screen. A, it's an angle. B, it's a side. C, it's a diagonal. D, it's I'm not paying attention. A, angle. B, side. C, diagonal. What is RT? A, angle. B, side. C, diagonal. Okay. All right, so let's review just for a moment what a diagonal is. Okay, what is a diagonal? A diagonal is a segment that connects opposite angles of your quadrilateral. So my quadrilateral or my parallelogram that I'm talking about here is in red, my RSTU. Any segment that connects opposite corners is the diagonal. So if you said that RT was a diagonal, you're right, and good job. If you said it was a side, maybe you weren't looking at the whole parallelogram, but instead focusing maybe on one of the triangles inside that you see. So just watch out for answering that question. We're talking about the red parallelogram, which means that RT is a diagonal. All right, so now that I know that RT is a diagonal, would SU be a diagonal too? Yes, Leanne, you're right. SU is also a diagonal. Very good. Let's go back to what we know about the properties of a parallelogram, and it says that diagonals bisect each other. So the diagonals are cutting each other in half. So RT is cutting US in half, and US is cutting RT in half. Well, if RT is 30, and I'm cutting it in half, what would be the length of each piece? 15. Very good, Camilla. Yes, thank you. So each piece is 15. Okay. It's also asking me questions about the sides. So let's look at opposite sides here. RU is here. So which other side would be 18? What other segment would be 18? Type it in the chat for me. Yes, very good. Anyone else? What other side would be equal to RU? Yes, if you said ST, you are correct. Opposite sides are congruent. So RU would have to equal ST, so ST is 18. With that same idea, I'm running out of colors, let's see. RS is 27, which means UT would also be 27. And there's one more piece of information here. It tells me that UV is 7. Anything else there equal to 7? What other segment would be 7? What do you think? You can type it in the chat if you know the answer. Yeah, Sarah, Andrew, you got it. John, Daniel, you rock. Good job. VS would be 7 because US is a diagonal and it's being cut in half. So if I have a segment, I cut it in half and I tell you that one half is 7, well, then you know that the other half also has to be 7. So VS is 7. Now that we've put all the information in the picture, I'm sure that we can probably answer all these questions. UT we labeled as 27. ST, we labeled that as 18. VS, we labeled that as 7. And VT, where'd VT go? There we go. We labeled that as 15. All right, let's do one more example here with some parallelograms with some angles this time. So I'm going to look at number 4. In number 4, we have a parallelogram, and it's telling me about angles. There's a very special piece of information down here at the bottom. It says the measure of angle FED is 134. A lot of times they put that information at the bottom because it's not super pretty to add to the picture. And if you look at angle FED, that's this whole angle right here. So you can see why I didn't put that in the picture. It would have made it kind of confusing. All right. Now we're going to kind of revisit what we learned way back at the beginning of the year when we learned angle addition. When we learned angle addition, we learned that we're going to have an angle that is split into 2 or more parts. And those smaller angles are going to add up to the large angle. Well, they just told me that large angle was 134. And this picture is showing me that angle FEG or FEC is 71 degrees. So how could I find that missing part? In the chat, tell me, what would you type in your calculator to find this missing angle? How would you find this missing angle knowing that the whole thing is 134 and that missing piece is 70, or that small piece is 71? Yay, good. Anybody else want to chime in there? What are you going to type in your calculator to find that missing angle? Yes, very good. All right, I'm seeing a lot of good stuff. All right, so just a reminder from our angle addition postulate, fancy word there. It says that you're going to add your 2 small angles together to get 134. And so to solve for that missing question mark, we're going to subtract 71 from both sides. So if in the chat you typed 134 minus 71, you're right. And that tells us that this missing angle right here is 63. Okay, so I'm going to put that in my picture, and I'm sure if I printed it, it would look a lot prettier than it does here. Okay, now we're going to deal with this 21. Remember that in our parallelogram, we have parallel sides, hence its name. So I've got some parallel sides here, and the transversal, or the line that intersects the 2 parallel lines. We're going to think back to Unit 3, where we have parallel lines and a transversal. What angle relationship would my visual here show? 2 angles in between the parallel lines, but on opposite sides of the transversal. Alternate interior. John, you're awesome. Good job, Camilla. You're right. Alternate interior angles are congruent. All right, so now let's see if I can get rid of all this big mess. How many times will it let me go back? Not enough. All right, give me just a second here. Got so anxious or excited to write these red lines, I didn't think about having to erase them. Okay. So this angle right here is 21, which means its alternate interior angle is also 21. Okay. We're almost there. Let's see what else can we figure out. Okay. Same along those lines, alternate interior angles means that this angle up here would have to be 71, and this angle over here would be 63 because they're alternate interior angles. Okay. Now let's think back. How could we find this whole big angle, CFE? I'm going to redraw that parallelogram over here at the bottom just because it's gotten kind of messy up there in the original. If I know that this angle is 134, how could I find this angle, the small one? It's consecutive angle. Okay. Well, we know that in a parallelogram, our consecutive angles have to be supplementary. So let's find that missing angle, 180 minus 134. 46. Okay. Why did I need to know that? Well, now that I know that this whole big angle is 46, I can find that missing piece using our angle addition again. If we have a big angle that's being split, the big angle is 46, and one piece of it is 21, what would be the missing piece? What do you think? So I'm currently looking at angle CFE, and we know that angle CFE is 46, and one piece of it is 21. So the other piece would be, thank you, Andrew. Thank you, Alexis. Thank you, Christian. It's 25, right? Because we subtract 46 minus 21, we get 25. Using alternate interior angles, we know that this dude over here is also 25. Man, that's a lot of information just from what, like 3 given numbers, right? Alexis, I can relate. In fact, have you ever noticed that the buttons on your calculator are opposite the buttons on your phone? You know how many times I have dialed the wrong number because I thought I was holding a calculator? All right, let's go ahead and answer the questions now. Remember, when you name an angle with 3 letters, the middle letter is your vertex, and you can just follow the letters in that order. So DEC, follow that in that order, DEC. See, I think that does 63. Yeah, it does. CDE, follow it in that order, CDE. Okay, well, CDE was the 25 and the 21 together. So that's 46 degrees. ECD, oh, we figured that out up here in green. That was 71. And DFE was down here in purple, 25. All right, so we had to use properties of parallelograms, knowing that the opposite sides were parallel so that we could use alternate interior angles. We had to know that consecutive angles were supplementary so that we could find that 46-degree angle. And I guess those were the 2 big ones that we used. We also had to use that angle addition postulate from way long ago, the ghost of the angle addition postulate. All right, so we're doing good on time here. We are going to jump ahead to talk about some rectangles. And all of these practice problems are going to be available to you with their answers when you go to practice these properties. Okay, but I want to make sure that we hit rectangles here too. Okay, so we've heard of rectangles, hopefully, right? A rectangle is a parallelogram. It has all of the properties of a parallelogram. All 5 properties that we just talked about, that's true for a rectangle. But what makes a rectangle special is that it has 2 more properties. And these probably are going to feel familiar to you because we've had a couple like random rectangles pop up, and you've been able to tell me that rectangles have right angles. So all rectangles have all 4 angles that are right angles. So all 4 angles are right angles. The other one is that the diagonals are congruent. So not only do the diagonals bisect each other, but they're also congruent. So I just want to draw a picture here for you real quick. Well, as best I can. Okay, here's a rectangle. It has 4 right angles. It has diagonals. And those diagonals are congruent. The diagonals are congruent and they bisect each other because of that parallelogram property. So each piece of the diagonal will be congruent. If I were to pull this rectangle apart into 4 triangles, how would you classify the triangles? So look what I have there in green. What kind of triangle is that? Can anyone remember? It's okay if you spell it wrong. What kind of triangle do I have there in green? Kristen, you got it. Maybe not the spelling, but that's okay. Anyone else? That's okay. I spell it wrong every time. Yeah, good job, Andrew. It's not equilateral, almost. You have 2 congruent sides, so you're looking at an isosceles triangle here. So not only do you have this wonderful rectangle with all these wonderful properties, but now we've broken that rectangle up into 4 isosceles triangles. So properties that you've now learned about isosceles triangles, they're all fair game too. You see how we just kind of build on each other here? Okay, let's do a practice problem with rectangles. Let's do one that uses everything. Number 5 looks good. So I'm going to skip ahead to number 5. You're definitely welcome to use those practice problems to practice the properties. I just want to make sure that I can cover as much as possible today. So we're going to look at number 5. In number 5, it says that DB equals 42. All right, let's ask this question again. I'll make it a little more clear. A, is it a no, angle, right? Okay, A is an angle. You're going to answer B if you think it's a side, C if you think it's a diagonal, and D, don't answer that one. Okay, so DB, what is it? All right, DB, what is it? Is it a side, a diagonal, an angle? Let's see, what are they? A for angle, B for side, C for diagonal. A for angle, B for side, D for diagonal. What is DB? That's what I'm asking. What is DB? Okay. Anyone else? What is DB? Is DB an angle? Is it a side? Is it diagonal? Thank you for nobody answering D. That was good. Okay, Aiden, thank you. I'll make note of that. That's good. If you said diagonal, you are correct. Okay. It's certainly not an angle, right? Because it's named with 2 letters, 2 capital letters. So if you're just looking at the name, you know that that's some kind of segment. So that's either a side or a diagonal. And it connects opposite corners of our rectangle. So that makes it a diagonal. So if you said diagonal, good job. Now let's actually answer the questions and delete all the stuff that I just put on the board. Oh my. Okay. So let's see. The reason we can't, they put it in words was because DB, that whole diagonal, no matter where they put that 42 might have been confusing, right? Because if they'd put a 42 in the picture here, you would have said, Miss Grandy, is that labeling DB or DE? So that's why they just put it up here in the directions and not actually labeled it in the picture. How I put it in the picture is I say, okay, DB is a diagonal. In a rectangle, diagonals are congruent and bisect each other. So half of 42 is 21. So instead of putting 42 in the picture, I just put two 21s in the picture. AD is 26. That's pretty easy to label. We'll go ahead and put a 26 over there. Let's work with the lengths first and then come back and work with the angles, just so we don't get ourselves too confused. If AD is 26, well, AD is a side. So that means that its opposite side will be congruent to it. Yay, good job, Camilla. I like your enthusiasm too. 26. Now we can also find AB. How on earth can we find AB? All right, let's use this property. Remember that a rectangle has 4 right angles. So now I'm really going to dredge up some old math for you here. Here we've got a right triangle. If you're in my honors class, we've worked with these a little bit. Right triangle. We know this is 26. We know the whole hypotenuse is 42. How do we find a missing leg? All right, does this sound familiar to you? Anyone remember the Pythagorean theorem? Give me a smiley face if you're like, oh yeah, I remember that. Pythagorean theorem, oh yeah, I remember that and I can use it. Smiley face. Meh face means I've heard of it and I think I've used it before. Don't really remember it a whole lot. All right, this is promising. Very good. All right, let's review the Pythagorean theorem just to help you out in case you're like, I kind of remember. The Pythagorean theorem, 1, only works for right triangles. So you got to have a right triangle in your picture. And in your Pythagorean theorem, A and B are your legs and C is your hypotenuse. Remember, the hypotenuse is always the longest side across from your right angle. So because I'm missing a leg, I'm going to make either A or B be that question mark. And it doesn't matter which one. I'm going to let it be B. I'm just actually going to just like, okay, this is B. I'm going to call it B. We're going to solve for that missing leg. So we'll say, okay, 26 squared. You could definitely use a calculator for this. And if you need help finding the square button on Desmos, please let me know. We can help you out find those buttons. 42 squared is 1,764. Please make sure that you are actually squaring the number and not accidentally finding the square root, because that will completely mess up your calculation. Now we're just solving for B. This is why at the very beginning of the year, I think it was like the first week of school, we had a whole bunch of like review algebra type lessons, and this was one of them, and this is why. If you would like any of those videos, again, I'm happy to send them to you. Just let me know. I'm going to subtract 676 from both sides. You'd think I would have this memorized by now. 1,088. And now I want to get rid of a square. Kind of alluded to this a minute ago. How do I undo a square? If you remember how to undo a square, type it in the chat. I don't care if you spell it right. How would you undo a square? What button would you use on your calculator? Or what symbol would you write on your paper? What undoes a square? Anybody? Yeah, Caleb, have confidence. You're right. All right. If you are using anybody still use a handheld calculator? Here, I'm going to put a poll up there. Give me a green check if you still use a handheld calculator. Nobody? Okay, one person. All right. Well, I'm going to show you anyway, especially for my few that do use the handheld calculator. Whether you're using a TI or a Casio or some other funky brand, if you look at your X squared button, Look at this symbol right above my x squared button. Do you see it? That's what undoes an x squared. In fact, maybe you've never noticed this about your calculator, but that's how the whole thing is set up. Like, here's an easy one. Oh, hold on, where's my camera? What undoes an on? What's the opposite of on? Off. Look at how I turn off my calculator. I hit the blue button and then I hit the on button and that turns it off. Let's see, what else undoes? All right, we're going to learn sine, cosine, and tangent in a little bit. I'll tell you that what undoes a sine is the sine inverse, or what's in blue ink right above it. What else can I show? What else undoes something? In Algebra 2, you're going to learn about a logarithm and a natural log. And what undoes those things is in blue ink right above it. So back to where we were, x squared. If you're ever not sure and you're using a handheld calculator, look at that x squared button, the square root's right above it. That's what's going to undo it. We can go into that and have a whole lesson on square roots. Okay, so back to where we were. We're going to do the square root of both sides. The square root of b squared is b, and then we're going to take the square root of 1088. And if you are using Desmos, make sure that you are using square root and not accidentally squaring this time. So square root 1088. It's about 32.9. All right, so now AB is about 32.9. I think on my answer key, I rounded it to 33. It will tell you what to round to on an assessment. All right, I think we can answer all of these questions now. Let's see. I'm going to give you, we're going to need those really fancy calculators. For an SOL course, no. Desmos is all you need for an SOL course. If you plan on going into a higher level math class like calculus or even like math classes in college, eventually you might want to get one and know how to use it. Yeah. It's also might be good, or even just to borrow one if you're ever taking like an SAT, because TIs and Casios are SAT approved, whereas a Desmos calculator you wouldn't be able to use on an SAT. All right, let's see. Let's answer the question here. AC. Well, my goodness, we just did all that, and now they're asking me for this diagonal. Well, remember the diagonals in a rectangle are congruent. So if DB is 42, now I know AC, because those diagonals have to be the same. EB, did we write that one? We did. We marked EB as 21. BC we marked as 26. AB, we did all that Pythagorean theorem work to find 32.9 or 33, depending on what you want to round to there. And that takes care of our lengths. Now, let's talk about angles. And I'm going to erase what I have here just because if I leave it and then we start talking about angles, it's going to get super messy. Okay, so I'm going to just erase what I have about the lengths and we're going to talk about angles. Okay. So it says that the measure of angle DAE is 52. DAE is 52. Believe it or not, that piece of information is enough to tell me everything about every single other angle you see in this picture. Okay. Well, let's start with the easy one. We know that in a rectangle, all four angles are right angles. So these are all 90. Cool. I'm going to focus on angle A for a moment. So I'm going to kind of draw it big. I know it's a 90-degree angle. And I know that this bottom part is 52. So how could I find that missing piece? What would you type in your calculator to find that missing angle? You know the whole big angle is 90 and part of it is 52. Thank you, Andrew. You're right. Very good. Oh, good. Camilla, thank you. Very good. If you typed 90 minus 52, you're right. We're using angle addition to prove that the small angle plus the small angle equals the big angle. So that means this small angle is 38. So I'm going to put that in the original picture. Okay, so now, because a rectangle is a parallelogram, that means that its parallel sides are going to make our alternate interior angles congruent. So what that means here is this angle down here is 38, and this angle over here is 52. Okay. Now I alluded to this a little earlier when I introduced the rectangles. We'll use green. I'm going to look at this bottom triangle right here. And we know that in our rectangle, our diagonals not only are congruent, but also bisect each other. So if I redraw this green triangle with these congruent parts and a 38-degree angle right here, what kind of triangle am I looking at? This green triangle, what am I looking at? What kind of triangle is my green triangle? Let's see, who answered this earlier? There's a lot of people. Yeah, Sarah, you got it. Andrew, I wouldn't agree. I don't think I would agree with your acute answer, only because you'll see when we find the vertex angle, it's actually not going to be acute. But thank you for answering. Yes, if you wrote isosceles, you're right. This is an isosceles triangle. And the reason why that's important is because now I know that it's isosceles. I know that its base angles are congruent. So if I go back to the original rectangle, that means this angle EDC, is 38. That's okay, Leanne. Not a big deal. And now let's find the vertex angle of that triangle. The three angles in a triangle will always add up to 180. So I'm going to do 180 minus 38 minus 38. And here we go. So this becomes 104, which is obtuse. So putting that up here in my picture, that becomes 104. Okay. Now I could do this process all over again if I wanted to, but hopefully you recognize that this top triangle, triangle ABE, is the same or is congruent to that triangle. So I know that this is 38 and this is 104. All right, maybe you can do it without redrawing it. Anyone know what angle ADE would be? This angle over here, angle ADE, what would be the measure of that angle? 52, thank you, Sarah. Yeah, because you've got another isosceles triangle over here on the side. So this becomes 52, which means angle CBE is also 52 because that's an isosceles triangle. And then you can find the vertex angle. You could take 180 and subtract 52 both times, or maybe you see a linear pair in there and you just do 180 minus 104. Both ways work. So we get 76. Wow, that's a lot of information just from knowing our properties and just from one number, right? Oh, good. Alexis, I'm glad that this is helping. Now all we have to do is answer the questions. And I do tell you that on an assessment, an SOL, a test, a quiz, just make sure you're reading those angles super carefully because the letters, you got to follow them in order. ADC. ADC is this angle right here. Who knows what angle ADC is? Anybody? Kelly, you're right. It's a 90-degree angle. Good. Thank you. It is. That's a 90-degree angle. So even though it wasn't labeled because we knew it's a rectangle, we can say that it's a 90-degree angle. Let's look at angle ABD. ABD, I'm just following the order of the letters. B is the vertex, so I see a 38 there. This is 38. And of course, angles are in degrees. BCA, we labeled that as 52. And DEC, we found as 104. So we found a lot more information in this picture than it was asking us for. But by doing that, we were able to answer all of the questions. Nice. So I highly recommend when you're taking an assessment, even doing practice problems, have a wipe off board or some scrap paper close by that you can redraw it or print it out so you can write on it. This is definitely not something that even I think I could do just by looking at the picture. You would definitely want to be, making note of what you're looking at and what information you see, just because there's so much going on in the picture. Okay, there's a lot of practice problems with rectangles. I wish we had time to do every single one, but I do want to make sure that we talk about rhombi. Rhombi is plural of rhombus. Maybe you just want to say rhombuses. Okay. Okay, so let's see. Here we go. A rhombus is a parallelogram. Every property of a parallelogram is also true for a rhombus. So what makes a rhombus special? Well, it has 4 congruent sides. So that's a little different than a parallelogram. Parallelograms don't have to have 4 congruent sides, but rhombuses do. So all 4 sides are congruent. Also in a rhombus, your diagonals are perpendicular. And the last one that makes a rhombus special is not only are its diagonals perpendicular, but the diagonals also bisect opposite angles. So that diagonal is going to cut the angle it's touching in half. Okay, so it has all the properties of a parallelogram plus 3 new ones. Okay, and I want to practice a practice problem with this and then talk about squares. Let's pick a practice problem. Let's see, I didn't do an algebra one for rectangles. Let's pick an maybe there wasn't one. Okay, let's see here. What's a good one? I think number 5 actually we're going to go to, since there's just most information I can share with you there. Okay, so we're going to use the properties of a rhombi or a rhombus and find all of these missing parts. If you're like me, I like to just work with the lengths first and then work with the angles. So that's what I'm going to do here. I'm going to put the given information in the picture. ZY is 34. Y or WY, okay, that's 38. That one's a little harder to label. A rhombus, remember, has all the properties of a rectangle or a parallelogram. So the diagonals bisect each other. So I'm just going to do 38 divided by 2 and mark each of these pieces as 19. So that way I don't get confused by putting a 38 in the picture. And we'll deal with this angle here in a moment. Let's work with the sides. Well, it's a rhombus, which means that all 4 sides are congruent. So that means these are all 34. And the diagonals bisect each other. So that's why we knew 19 and 19. It does not mean that the diagonals are congruent. Okay, so we don't know anything about ZX yet. We will in a moment. Remember that your diagonals are also perpendicular. And the reason why that's important is because by doing that, it now has 4 right triangles. And we can use our friend, the Pythagorean theorem, to help us find the missing side of our right triangle. Isn't WX also 34? Yes, WX is 34. Good job. Okay, so let's find our missing leg. A squared plus B squared equals C squared. A and B are the legs, so let's call A the missing leg. 19 is the other leg, and 34 is the hypotenuse, or the longest side. Well, 19 squared is 361. Of course, I'm running out of room. 34 squared is 1,156. I'm solving for A, so I'm going to subtract 361 from both sides. I get a squared equals 795. And to undo a square, we square root. So second square roots. Here we go. That's about 28.2. So this missing diagonal piece is 28.2, which means this diagonal piece is 28.2. And it would always tell you what to round to on your assessment. All right, that's all of the lengths. We should be able to answer the length questions here. Let's see, WZ, 34, that was a side. VY, VY is half of this diagonal at 19. ZV, we found that when we did the Pythagorean theorem, 28.2. And ZX, okay, well, ZX is this whole entire diagonal. So we can do 28.2 plus 28.2 and get 56.4. All right, so that's sides. Now let's look at angles. I think the angles might be a little easier here because you don't need a Pythagorean theorem for angles. Let's make this look pretty again. Okay, so in our rhombus, the diagonals are perpendicular. So I'm going to put a right angle here. And it tells me the angle ZXY is 34. ZXY, so this is 34. All right, well, we know that, I could have put the right angle here. I could put it here or here or here. They're all right angles. So if I'm looking at just this triangle right here, the three angles in that triangle must add to 180. So I'm going to do 180 minus 90 minus 34 and get 56. So this angle right here is 56. Now I have everything I need to know to put the rest of the angles in here. Okay, not only did it make it into 4 right triangles, these diagonals broke this rhombus into 4 congruent right triangles. That's pretty cool. We wrote down that the diagonals bisect opposite angles. So angle X is being bisected by that diagonal, which means this is 34 over here. And this is 56 over here. And this would be, these two would be 34. And these two would be 56. You could think of it different ways. You could say, oh, well, the opposite angles are congruent because it's a parallelogram. You could say the alternate interior angles are congruent because it's a parallelogram. Those are both ways to think about it. So now we can answer all the angle questions. WXZ, well, there we go. We labeled that as 34. WVZ, well, that's 90. ZYW, ZYW is 56. And XYW is 56 again. Okay. Lots of properties. Okay. We have one more type of quadrilateral to talk about, and that's a square. Not a whole lot to write here. You've already written all of the properties because squares have properties of everybody we just talked about. The square has all of the properties of a parallelogram. It has all of the properties of a rectangle, and it has all the properties of a rhombus. So every property we just talked about is true for a square. I like to think of these quadrilaterals as kind of like a family tree. Not 100% like a family tree, but you could think of it that way. You could say, oh, well, we have our parallelograms. Those are our grandparents. There they are, parallelograms. They have all these properties, right? Their opposite sides are congruent. Their opposite sides are parallel. Their opposite angles are congruent. Their diagonals bisect each other, and so forth. Well, then with those parallelograms, they have a rectangle. And a rectangle has all of the property of the parallelogram plus its own properties. Congruent diagonals, 90-degree angles. It also has a rhombus. A rhombus has all of the properties of a parallelogram, but it has its own properties that makes it special. Its diagonals are perpendicular and its sides are all equal. And now here's where my family tree illusion kind of falls apart. If it's a square, it has the properties of the rectangle. It has the properties of the rhombus. It has the properties of the parallelogram. Okay, so I don't know if that helps you remember all of the properties that they share, but maybe it'll help. Okay, before we do a practice problem with squares, I want to give you your attendance word. Your attendance word is opposite. The attendance word is opposite. Write that down, circle it, highlight it, do the hokey pokey, and then make sure you have that so you can do the attendance quiz. Opposite. Yep. You make sure you spell it right too in the attendance quiz. And make sure you do the correct attendance quiz. Like if you were missing one for some reason, make sure you put the word opposite in today's attendance quiz. Because if you put it in Monday's, it's going to be wrong. All right, I think we have time to do one example for a square. Let's look at the squares. Let's find one. I like number 6. We'll do that one. And number 6, it says that ABCD is a square. AD is 11. So I'm going to go ahead and mark 11. Now, because it's a square, that means it has all the properties of a rhombus. So all of the sides are congruent. AD is 11. So now we can find the length of the diagonal. How would we do that? Well, because it's a rectangle, we have 4 90-degree angles, which means we have a right triangle. So I can use the Pythagorean theorem to find the hypotenuse. A squared plus b squared equals the hypotenuse squared. You could type this straight in your calculator if you wanted. 100. Oh, it's not squared. 121 plus 121 is 242. And to undo that square, you're going to square root. So find the square root of 242. And it's about 15.6. So your hypotenuse is about 15.6, whole thing. Let's see, if it asks us for half of the diagonal, we'll have to divide that by 2. Let's see. BC, okay, that's 11, that was a side. AC is a diagonal. The diagonals are congruent, and it gets that property from being a rectangle. So 15.6. BD, well, that's the other diagonal, still 15.6. And EC, we are going to have to divide by 2. EC is half a diagonal, so we'll do 15.6 divided by 2. And 7.8. Okay. So from in the square, I had to know the properties from the rhombuses, having 4 congruent sides. I had to know a property of the rectangle, having a 90-degree angle, so that I could use Pythagorean theorem. Now let's see about the angles. It didn't give me any information about the angles. How on earth am I supposed to do this? Well, remember, we got 4 right angles from being a rectangle, and from being a rhombus, its diagonals are also perpendicular. So let's see if we can answer any of those questions. DAB. Oh, that's a 90-degree angle. AEB. Oh, that's a 90-degree angle. CBD. CBD is here. But remember, in your rhombus, the diagonals bisect the opposite angles. So if I bisect a 90-degree angle, each piece will be 45, half a 90. And BAC, same idea. BAC would be this angle over here. I'm going to bisect that 90-degree angle or cut it in half. So that's going to be 45 also. Of course, they're all in degrees. And on an assessment, I'm never going to ask you to type the degree symbol. It'll already be there for you. Whew. All right. There are a lot of practice problems for parallelograms, rectangles, rhombi, and squares. These are not new properties. These are properties that you should have at one point learned before. And if not, that's okay. We're here to review those. When you're looking at a problem, you want to ask yourself, what shape is it? And what is labeled? And once you can answer both of those questions, you should be able to figure out what the relationship is you're looking at. So if you're looking at a square and you're looking at some sides, you know that the sides are going to be congruent. If you're looking at a parallelogram and you're looking at diagonals, you know they bisect each other. And how did I memorize these so much? I've used them and I've done so many practice problems that I remember them. I didn't sit down and just memorize them in a day. I practiced the problems and I practiced using them in a problem. And I highly recommend the same thing for you. There are a lot of practice problems just in these notes that we didn't cover. The key is posted to Edmodo if you want to check any of them. And there's also a lot of practice problems on OMHS after the exit ticket. You're welcome to practice there too. If you would like additional practice problems, just reach out to me and let me know. I've got lots of resources for you, and we can practice these properties as many times as you need to get them to stick. Okay. I highly recommend doing some practice problems before jumping into that exit ticket. Okay, so if you're jumping straight into the exit ticket, I don't recommend that. Make sure that you do a couple practice problems first and know the properties. Whew, that was a lot. Hopefully this was helpful for you. I'll stick around here for another minute or two to answer any questions you have. Otherwise, I hope you have a wonderful day.